Corpus Christi, Texas, a city pressed against the Gulf of Mexico, facing an endless ocean. And yet, it is thirsty. For decades, the city believed it was nearly immune to drought, thanks to two massive reservoirs and an inland water delivery system. But by 2025, water levels had fallen to only about 10% of capacity. A coastal metropolis found itself forced to ban lawn watering, car washing, and strictly ration every household gallon. Under that pressure, Corpus Christi chose a bold path: drinking seawater. Texas plans to build a desalination plant right in the port, turning the Gulf of Mexico into a new water source. But desalination does not only produce fresh water, it also creates highly concentrated brine, something that could quietly alter the ecosystem on the floor of the Gulf. So what did Corpus Christi do? How can it secure enough water without turning part of the Gulf of Mexico into a biological dead zone? Let's explore with Terran Works right now. Corpus Christi is not just a coastal city, it is a strategic link in the United States energy system. The port of Corpus Christi is currently the nation's largest crude oil export port, handling more than 2 million barrels per day. Along the Gulf Coast, petrochemical complexes and polymer plants operate 24/7, consuming millions of gallons of water daily for cooling, processing, and pressure maintenance. Here, water is not merely for daily life. It is the silent engine of a multi-billion-dollar economy. But behind that prosperity lies a structural vulnerability. The city's freshwater supply depends almost entirely on rainfall and inland runoff. When the climate shifts, the entire system begins to tremble. Over the past 2 decades, rainfall has trended downward, while summer temperatures have repeatedly set new records. Evaporation has intensified, inflows have declined, and drought cycles have become longer and more severe. In 2023, the region was forced to activate strict water restriction stages. By 2025, available reserves dropped to alarming levels, pushing the city into a defensive position. Dependence on surface water has effectively turned Corpus Christi into a hostage of the weather. And as drought persists, it is not only daily life that is threatened. The national energy supply chain itself faces growing risk. In this context, seeking a water source independent of rainfall is no longer a bold option. It has become an inevitability. To understand why Corpus Christi has become so vulnerable, we need to look back at the foundation that sustained Texas for more than half a century: its system of artificial reservoirs. The state's prosperity was built on massive dams and vast reservoirs. In South Texas, Lake Corpus Christi and Choke Canyon Reservoir serve as the lungs supplying water to the entire region. Constructed in the mid-20th century and expanded in the 1980s, they were once seen as symbols of humanity's ability to control nature. Engineers believed that with sufficient storage capacity, drought would no longer pose a serious threat. But time is steadily eroding that confidence. Sediment accumulation over the years has quietly reduced the actual capacity of many reservoirs. According to data from the Texas Water Development Board, some reservoirs in the state have lost between 20 and 25% of their original design storage capacity. In other words, the water reserve system is gradually shrinking, even as demand continues to rise. At the same time, average temperatures across Texas are climbing. In summer, wide and shallow reservoir surfaces become enormous mirrors exposed to 40 degrees Celsius heat. In some areas, the volume of water lost to evaporation each year can equal, or even exceed, human consumption. When the reservoir system could no longer carry the burden, Corpus Christi was forced to turn toward the sea. That was when the Inner Harbor Project was born, a high-stakes gamble worth hundreds of millions of dollars to build Texas's first large-scale seawater desalination plant dedicated to municipal drinking water. In principle, the solution sounds simple. Water from the Gulf of Mexico would be drawn in, pushed through reverse osmosis membranes to remove salt and impurities, and then delivered as fresh water into the city's distribution system. The first phase is designed for a capacity of about 30 million gallons per day, enough to offset much of the projected shortfall over the next decade. But the technology is far from cheap. Compared with traditional surface water treatment, desalination consumes 5 to 10 times more energy. To produce a single gallon of fresh water, the system must use substantial electricity to generate the high pressure required to force seawater through filtration membranes. That means higher operating costs, higher water bills, and, in a state where energy production still relies heavily on fossil fuels, increased carbon emissions. Moreover, the inner harbor site lies deep within the port of Corpus Christi, where water circulation is slow and natural flushing is limited. Environmental experts worry that any impacts from the plant could accumulate locally rather than being quickly diluted offshore. For that reason, this is not merely an infrastructure project. It is both an economic and environmental test. Did you know that every gallon of fresh water produced from the ocean leaves a trace behind? In every reverse osmosis desalination process, salt does not simply disappear, it is separated. For every gallon of clean water delivered into the system, nearly an equivalent gallon of highly concentrated wastewater is created. This mixture, known as brine, is 1.5 to 2 times saltier than natural seawater and also contains residual chemicals such as chlorine and anti-scaling agents used to protect the filtration membranes. Brine is denser than seawater, so it does not dissolve quickly or rise to the surface. Instead, it sinks to the seabed and spreads slowly, reducing dissolved oxygen levels and altering the chemical balance near the ocean floor. In many Middle Eastern regions, such as Saudi Arabia and the United Arab Emirates, home to the highest concentration of desalination plants in the world, studies have documented localized increases in salinity and clear impacts on coastal ecosystems. In Corpus Christi, concerns are even greater because the proposed discharge site lies within a semi-enclosed harbor, where weak currents and limited natural dilution capacity could allow the brine to accumulate over time rather than disperse quickly into the open ocean. If brine is a chemical concern, its real impact would unfold on the floor of the bay. Beneath the seemingly calm surface of Laguna Madre and its surrounding bays lie vast seagrass meadows stretching across tens of thousands of acres. This is not ordinary grass. Seagrass forms the biological foundation of Texas's entire coastal ecosystem. More than 70% of the state's commercial seafood species, from shrimp and blue crabs to red drum, spend part of their larval stage within these underwater meadows. They serve as nurseries, shelter, and feeding grounds. Lose the seagrass, and the food web begins to unravel. Yet seagrass is extremely sensitive to changes in salinity and water quality. If salt concentrations near the seabed rise beyond tolerable thresholds, especially in areas with weak currents, these meadows can decline rapidly. When they die, their roots no longer anchor the sediment. The seafloor becomes disturbed, the water grows more turbid, and light penetration decreases. Less light means less photosynthesis, and the spiral of degradation begins. The consequences are not only ecological. Texas's coastal fishing and tourism industries, worth billions of dollars each year, depend directly on this ecosystem. If the seagrass disappears, key species are likely to decline with it. That is why the desalination debate is no longer just about technology. It becomes a fragile balancing act between human survival needs and the stability of an ecosystem that has endured for generations. When surface water becomes unstable, Texas is forced to search for stability in the deepest place possible, underground. Hidden beneath the Gulf Coast lies the Evangeline Aquifer, a vast groundwater system formed over hundreds of thousands to millions of years. It is often described as the region's natural vault, storing enormous volumes of fresh water that do not depend directly on unpredictable rainfall. As reservoirs decline and desalination remains controversial, Evangeline appears to offer a safer alternative. But this reserve is not limitless. History has already revealed the cost of over-extraction. In Houston, intensive groundwater pumping throughout the 20th century caused severe land subsidence. In some areas, the ground surface dropped by more than 3 meters within just a few decades. When water pressure decreases, the surrounding sediments compact, lowering natural elevation and increasing flood risk, a clear threat to coastal cities that already face frequent hurricanes. Excessive pumping also opens the door to saltwater intrusion. As freshwater levels fall, seawater can migrate into the aquifer, contaminating the reserve and rendering it unusable. Evangeline, therefore, is not a bottomless well. It is a long-term asset that requires precise and disciplined management. If treated as a quick fix, Texas may trade long-term security for short-term relief, and the consequences would not be easily reversed. To search for answers for Texas, look to the other side of the globe, Singapore. This island nation covers less than 730 square kilometers, has virtually no large rivers, no natural lakes, and once depended heavily on imported water from Malaysia. For decades, water security was considered one of Singapore's greatest strategic vulnerabilities. Yet today, it is often called the world's water management capital. Its success did not come from a single solution. Singapore built what it calls the 4 national taps: locally collected rainwater, imported water, high-tech recycled water known as Newater, and desalination. Among them, Newater became a critical breakthrough. Wastewater is treated through microfiltration, reverse osmosis, and ultraviolet disinfection, meeting standards set by the World Health Organization before being returned to the system. Today, recycled water supplies roughly 30 to 40% of national demand, and that share can rise even higher. At the same time, nearly 2/3 of the island's land area is engineered as a massive rainwater catchment basin. Every rooftop, every roadway forms part of the urban water infrastructure. Not a single drop is allowed to go to waste. Singapore demonstrates that the challenge is not merely about supply, but governance. Instead of betting on one single fix, it built a layered, flexible system designed to withstand risk and uncertainty. If Singapore demonstrates the power of governance and high technology, then on another corner of the world, Morocco tells a very different story. Simpler in appearance, yet no less remarkable. In the Anti-Atlas Mountains, where annual rainfall is extremely low and groundwater is often too salty or too deep to extract, communities did not build $100 million plants. Instead, they erected tall polymer mesh nets to harvest fog. When moist clouds roll in from the Atlantic and sweep across the slopes, microscopic droplets cling to the mesh fibers, condense into larger drops, run into collection troughs, and are channeled into village storage tanks. In areas such as Mount Boot Mesgida, fognet systems stretching across thousands of square meters can capture thousands of gallons of water per day during peak fog seasons. They require no massive electricity input, produce no emissions, and have minimal operating costs. This solution cannot replace national-scale infrastructure, but it proves something essential. Water can come from unexpected sources when people truly understand their climate and terrain. Morocco does not confront nature with pressure and steel. It observes, adapts, and works with what already exists. Texas may not have the dense fog banks of the Anti-Atlas, but the lesson here is not about a specific technology. It is about mindset. Diversify solutions, combine large-scale infrastructure with local innovation, and always consider the ecosystem before acting. In a world growing steadily drier, flexibility may prove more valuable than any single mega project. Corpus Christi is not the first city to face a water crisis, and it certainly will not be the last. From shrinking Texas reservoirs to desalination plants, from deep aquifers to fragile bay-bottom ecosystems, every proposed solution carries consequences. Singapore has shown that a diversified, multi-source system can create long-term stability. Morocco has demonstrated that sometimes the answer is quite literally in the air. But in Texas, the final decision has yet to be made. What do you think about desalination? Is it a lifeline or an environmental risk waiting to unfold? Leave your thoughts in the comments below. And don't forget to subscribe to Terran Works as we continue exploring the hidden systems shaping our world.